Okay, first thing you should have taken away from the video. How do I name an angle and what's the symbol when I write it symbolically? All right, so up here I have an angle. I have D, E, and F on that angle. Couple ways you can name the angle. First, angle symbol. Okay, you don't have to have the little arc mark like I have on there, but both are correct. You can name it with 3 letters. So D, E, F, angle D, E, F. As long as, when you name it with 3 letters, the vertex is in the middle of those 3 letters. Other way you can name it, you can name this angle E. Just name it by the vertex. Both are acceptable. We good? Okay, here's where kids run into problems, and that's the next example. The green arc mark means, how do I name the whole angle here? How do I name the whole angle? You cannot name the whole angle angle E. Do you see why I cannot name it angle E? Because there are multiple angles within this diagram that have E as the vertex. So you cannot name it angle E. You are forced to name it with 3 letters. Okay? Bottom line, you can never go wrong if you name an angle with 3 letters. Okay? You can get in trouble if you name it with just 1, like you saw here in this example. Okay? And the final thing, and this was probably the most important thing I needed you to get from the video, is this new vocabulary term, bisex. Bisex. What happens to an angle when I bisect it? It is being cut in half, being cut into 2 congruent angles. So up here, if I say BD bisects ABC, that tells me that angle ABD, everyone look at that angle, ABD is congruent to angle DBC. Okay, cuts it into 2 congruent angles. Last thing, how do you mark your diagram to say 2 angles are congruent? On segments, we put hash marks. We don't put hash marks on angles. Anybody remember from the video what we put? Little arc marks, absolutely. We put little arc marks here that say they're congruent. Okay, so get used to that. Hash marks are for segments, arc marks are for angles. All good? All right, so those are the 3 main takeaways I needed from the video. Okay, and hopefully you guys are starting to feel a little bit more comfortable with your compass, but we'll have a whole day tomorrow, I think, dedicated to using your compass. So make sure you guys have your compass at home tomorrow. You guys coming in tomorrow, make sure you have your compass and straight edge in class tomorrow. All right, whole day is dedicated to using your compass. All right, let's get to the homework. All right, again, let me preach this again. If I go over an example, you guys that are turning it on Google Classroom, that example better have work and it better be all correct. All right, if we're going over it, don't waste our time. Make sure your work is correct before you submit it into Google Classroom at 1 o'clock today. All right, let's open it up. Questions from this past weekend. You had a couple algebra problems to do, and you had to rename a couple angles too. Anything we want to go over at home or you guys here? Making sure we get this down pat because we're doing more with angles today, and it builds on that Ed puzzle video you watched.
Question 25. I can understand why angle 4 is one of the angles that's right here, but I also put angle PQR as an option.
PQR, that's just a different way of naming angle 4, so that's fine. Angle 4 and angle PQR are the exact same angle.
Wait, so even though the 4 is in the inside of the angle, it's still
you can name it angle 4. Yep. You can name it by the numbers or you can name it by the letters like you did.
But the number can be on the inside of the angle, right? It doesn't need to be on the outside of the
No, it better be on the inside if you're going to call it angle 4. Yep. Okay. So either a response is fine there. Angle 4 or angle PQR, same angle we're talking about. Yep. Other questions? Anything with the algebra we want to look over? Because when you guys hand it in, when I walk around, I'm going to look for the algebra, just not the final answer. Last call before I go around and check with these guys. Anything at home? Okay, here we go. Give me a second. I'm going to walk around, check these guys. You guys get ready for today's notes at home and make sure that homework's due by 1 o'clock on Google Classroom. All right? Okay, guys. I already checked, too, that you guys watched the puzzle video, so that's all taken care of. Good. Looking for some algebra at the end there. Perfect. Oh, thanks, guys. Good. Good. Algebra there. Yeah. Yeah, I probably checked this already, but second time's fine. All right, good guys. Thank you. Okay, here we go. Let's get ready for today. If you guys have a calculator, let's get that out. You guys at home have a calculator ready, whether it be on your Chromebook or in your hand. Just checking off some of you guys that are here today at home. We can just stare at each other awkwardly. That's fine. So I get this done. Atticus, are you on?
Yeah.
Okay. Anthony, are you on?
Yes.
Okay, thank you. All right, here we go, guys. Let's get this party started today. All right, more work with angles today. More work with angles. All right? Different types of angles. Pairs of angles together now. So the first one I want to talk about, adjacent angles. If you just hear the word adjacent, anything pop into your mind right away, forget about math or I'm just talking life here. If you hear the word adjacent, I live adjacent to Bobby. Anything? My house is adjacent to Sarah's house. What's that basically telling you? We live next to, thank you. We live next to, adjacent, next to. Okay? So you can think of adjacent angles are angles that are next to each other, but they got to fill three criteria. Ready for the three things that have to happen? They have to have a common vertex in common, and then they have to have a side in common. And I'll work with you on this last point. They cannot have any interior points in common. I'll work with you that in a second. All right, so let's look at letter A. Everyone see angle X and Y? Everyone see the two angles I'm referring to first. Are they adjacent or not? Well, I'm going to pick somebody right now, and you're going to go through this checklist with me to see if it fulfills the conditions to be two adjacent angles. There it is. I know we don't have 14. What do we have here? 26, I think, looks like. Okay, here, 14, which would be Ellie. Ready? Ready to go, Ellie? I got a couple questions for you. Ready?
Yes.
Okay, ready. First thing, do they have a common vertex?
Yes.
Yep, I'll show everyone right now. There it is. There's the common vertex, that little dot I just put on there. Do they share a side, Ellie? Angle X and angle Y, do they share a side?
No.
No? Here's X, ready? Here's X. There's angle X. And there's angle Y.
Oh, yeah.
Yeah, they do. Everyone see the side they share there. Okay, perfect. All right, now, what do I mean by they have no interior points in common? Everyone right now, put a point somewhere inside angle X for me. Everyone go ahead. Just put a random point somewhere inside angle X. Is that point also in angle Y? No. Can you put a point anywhere in X that will also be in Y? I don't think you can. That means they have no interior points in common. So, going back to you, Ellie, can we say that these two are adjacent then?
Yes.
Yes, we can. So this is an example of two adjacent angles. All good. Okay, what about my next pair, X and Y, for part B? Are those two adjacent? It better have all three that we need in the definition. Okay, here we go. 5. Let's go. Hayden, ready? Do they have a common vertex?
No.
No, done. I don't even have to check the other two if they don't have a common vertex. Why? Because take a look. Here's the vertex for Y. Here's the vertex for X. They are not in common. So these are not adjacent. Okay, next one, just so you guys know what angle X and angle Y are. Here's angle X in pink, and here's angle Y in beige there. Okay, so that's just so you know, that circle kind of screws with you a little bit. All right, so X is the pink one, Y is the beige one. Here we go. Let's figure out, are they adjacent or not? 24, here we go. Emily, ready? Do they have a common vertex?
Yeah.
Check, they do. Do they have a common side?
Yeah.
Yep, it's that vertical ray right here. Okay, ready? Is that point also in Y? Is that point also in X? Can I get a point that's in both at the same time? No. So what can we say about these? They're adjacent angles. Good job, Em. So these are adjacent angles. Everybody all good? Yes.
What if you have a point directly on the line?
Point directly, that would be interior then.
Okay.
The point's got to be inside the angle, not on the angle. Good? Okay, good question. All right, next, last one. Just so you guys know, ready? Angle Y is referring to this angle right there, okay? And angle X is the full angle right here, guys. Angle X is the full angle. Everyone see the two different ones right now? So Y is the smaller one, and then X is the entire thing. All right, don't fall into the trap here. 7, here we go, St. John, ready? Do they have a common vertex?
Yeah,
Yep. Do they share a common side?
yeah.
Yep. Okay, here we go now. Here's where you got to be careful. Could I put a point in one angle that's in the other?
I think so.
Yeah, you can. Watch, guys. Hey, look. Everyone see that point I just put in inside angle Y? Isn't it also inside angle X? I can't have points that are in common. So what, Sinjin, what can we say about these two?
They are not adjacent.
They are not adjacent, correct. And again, if you're still confused, make sure you know what angle X is. Angle X is this full thing here, okay? So is everybody good? All right, I probably spent a little bit more time on that than I needed to, but making sure we're good on this first concept. Questions, comments, concerns? All right, now we can rock and roll. Complementary, we've heard of that before, right? Two angles, you just got to remember which one's 90 and which one's 180. Complementary adds to 90 degrees. So let me first show you what you're used to back in the elementary school days. Oh, hi, I'm a 40-degree angle. Hi, I'm a 50-degree angle. Together, they are complementary. Everybody agree? Oh, that was good old days, right? Elementary school, or recess, some snack time, right? Well, we're in big boy, big girl math now, the high school. You are not going to see that anymore. Here's how you're going to see two complementary angles. Oh boy, new symbol there. I did not put a single degree measure on there. But how do I know they're complementary? Angles 1 and 2. I did not put a single degree measure on. So how do you know those two add to 90? Maeve, go ahead. Maeve, go ahead, Maeve.
There's a box.
What's the box mean? What's the box mean? That forms 90 degrees. So if you put the two together, they add up to 90. They're complementary. All good? Okay, that's complement. Oh, forgot something really important. Complementary is for 2 and 2 angles only. That's it. If you have 3 angles that add up to 90, anybody know what we call that? 3 angles that add to 90. Okay? Complementary is reserved for 2 angles only. Everyone good at home? All right, supplementary. 2 angles that add to 180. So I'll do the same thing again. I'll give you the elementary school version. Hi, I'm 120 degrees. Hi, I'm a 60-degree angle. So you guys know that they add up to 180. Well, that's cute. All right, high school version. Here it is. One and 2 are supplementary. How do I know? I didn't even put any angle measures on again. How am I guaranteeing that those 2 angles add up to 180 to be supplementary? two angles only. Sabrina? Nope. Who's Sabrina? Second. Okay, Sabrina, go ahead.
A
Name.
line.
Name.
Oh, Radhika.
Radhika, go ahead. Got it.
A line equals 180 degrees.
A line equals 180. You guys learned that in the Ed Puzzle video, right? Straight line equals 180. That's a straight line, so 1 and 2 have to add up to 180. Everybody good? Supplementary, complementary. All right, let's keep trucking. Linear pairs. There we go. Linear's got the word, not ear, line in it. Linear's got the word line, so it's two angles that form a line. Two angles that form a line. They have to be adjacent as well. Two adjacent angles that form a straight angle. So we're going to go through A, B, and C, and can you tell me if they're linear pairs or not? All right, can you tell me if they're linear pairs or not? 4, here we go. Gideon. In part A, are angles 1 and 2 a linear pair? Are they adjacent angles that form a straight line?
No.
No. Everyone agrees they're adjacent, but they don't form a straight line. They got to form a straight line. Okay, how about part B? Part B. 12. Here we go, Lucas. Are those a linear pair?
No.
Why not?
Because on a linear thing, they have to be 90 degrees. 90.
Who said they had to add to 90? Ready? Linear pairs. They have to be adjacent. Are they adjacent?
Yes.
Do they form a straight line if I put them together, 1 and 2?
Yes.
Okay, so therefore they are a linear pair. Has nothing to do with nothing.
They have to add to 180.
There you go. There you go. Yes, yes. Not 90, buck 80. All right, how about part C now? What about those two? Look like a linear pair to us? 18, not here. 26, here we go, Emma. I don't know why I just said that again. Linear pair? No.
No.
Why not? There's a lot of reasons. But what's one reason why they're not a linear pair?
Oh, they
They don't make a straight line. And number 2, are they even adjacent? No, they're not even adjacent. They don't share a vertex. Everybody all good? All right. Big moment right now in your geometry careers. You're going to learn your first theorem. First, what is a theorem, first of all? You guys have probably heard of Pythagorean theorem, right? Here's what a theorem is. It's a true math fact. Okay, a true math fact that you're going to learn. You're going to learn a ton of them this year. Here's your first one. And you guys are going to fill in the blanks for me right now. Linear pairs are blank. And you guys are going to help me fill in the blank right now. Linear pairs are blank. And I don't want adjacent because that's part of the definition. If you know two angles form a linear pair, like in part B, and my example up here, 1 and 2, those are linear pairs. What do you know about them? Again, don't tell me they're adjacent. I know that. That's part of the definition. But if I see a picture and I see linear pairs, I know those two are supplementary. There we go. Don't tell me adds to 180 right anymore. We have a vocabulary term for that. Supplementary. So if they're linear pairs, they're supplementary. Take a breath. Woo! Everybody all good? You better buckle up when you get to this class, right? It's like a roller coaster. I didn't want to go backwards. Here we go. Star. Star, anybody? Star? Hopefully you guys are starting to learn these because next week, star 2 in a row. I'm going to add a little something to this. All right. Ready? Vertical angles. Anybody ever heard of verts before? Vertical angles, maybe? Okay. Here, vertical angles are formed when you have two intersecting lines. So everyone take a look. I've already have two intersecting white lines here. How many angles are formed when two lines intersect? How many angles? 4. Yeah. Watch. Ready? 1, 2, 3, 4. The ones that are opposite are vertical. Okay? The ones that are opposite are vertical. So we're talking 2, 4, and 1 and 3. Those are vertical angles. Everybody good? Can you identify them for me right now up on the board? A, B, and C. Let's start with A. And I'm going to be ready to get challenged here. It's going to be more than a yes or no here for me. Get ready to get challenged here. Oh, going right to the top. Vinny, you better be ready. R1 and 2. What's that? I'm going to ask the questions. R1 and 2 vertical.
No.
No. Good. But I'm still going to challenge you. Give me a name for 1 and 2.
Adjacent angles.
More. Give me more. You're right, but I want more now. Because you have more vocab.
Supplementary.
What?
Supplementary.
More. What's adjacent? What are two angles that are adjacent and supplementary called? We just went over it.
Linear pairs.
Linear pairs. Yes. They're linear pairs. Everybody good? Knowing the vocab. Good job, Vinny. How about the next part? Are those two vertical? Ooh, boy. Oh, boy. Sabrina.
No.
No, good job. A lot of people are like, wait a second, Sabrina. Those two are opposites. But they have to be formed by two intersecting lines. Those aren't lines. Okay, lines are straight. Everybody good? They're not vertical. And then how about part C? Are those two vertical? Let's roll. Oh, Vinny, going back to you.
Yes, they are.
Yeah, they are. Woo! Good job, kids. Anybody questions? Ooh, your second theorem of the day. So we had linear pairs are what? Supplementary. Now I'm going to have vertical angles are blank. If two angles are vertical, what should I know about them? Woo! You guys are going to help me find that fact right now. You're going to help me find that fact. Here we go. Radhika, you ready? I don't want the answer. Here's what I want. Give me a random angle measurement for angle 1 up here.
30.
30. Perfect. I like it. If that's 30, what's angle 2 then? Oh boy.
180 minus 30.
150. Good job. Keep going with me. What's angle 3 then?
30.
And what's angle 4?
150.
Okay. You know where the vertical angles are. What do you know about them?
They're congruent.
Oh, she didn't even use the word equal because we got a better word for equal, and it is congruent. Good job. Any two vertical angles will always be the same measure. They will be congruent. Good job. Nice. Nice. Anybody, anything else? I think we got one more vocabulary term. We good? Whew, I think you heard of this one before. Perpendicular. Perpendicular. Two lines that form right angles. And again, what's the symbol I can put on my diagram to show there's a right angle existing? I can put a little box. Anybody know why just putting one is okay? Why didn't I just put 4 of them here? Like, why did I do this? Why is that not necessary and just ridiculous? Anybody know why 1 is just fine? Go ahead, Radhika.
Well, the one where you put the box and the one across from it are vertical.
Okay, these are vertical, so they're congruent, right? So that's got to be a right angle. And then, sorry.
This is, if the one with the boxes are 90, then the other ones have to be 90 because they should add up to 1.
Yep, they should be supplementary, so that's got to be 90, that's got to be 90. That's why putting only 1 is fine, everybody, okay? Only put 1. Okay, let's put some, we'll call this line AB and this one line CD because we need a new symbol. We need a new symbol. So I have line AB, as we know from before our quiz, and I have line CD. All right, kids, I do not want to write the word perpendicular, nor do you every time. Anybody know the symbol for perpendicular, the mathematical symbol for perpendicular? Nobody in first period knew it. There's a challenge to you. Nobody in first period knew it. They got pretty close, but they didn't know it. Maeve, you got it?
It's like a line with another, it's like this. I put like on this part, like, I don't know how to say it. Like,
I don't know what we're doing. Charades now. Upside down.
Is it an upside down T?
Upside down T. There we go. There it is. That is the symbol for perpendicular, everyone. Get used to it. So if you need to make a note, that's the symbol for perpendicular. Yep. Okay. So I just threw a ton of vocab at you right now. You ready to practice it now? Okay, are you ready to practice all this new vocab? All right, take a look at my beautiful diagram up there. And in your notes, can somebody give me an angle that is complementary to angle BOC? All right, again, locating an angle. Even the honors kids have trouble sometimes locating where the angle is. BOC, follow the order of the letters, B to O to C. So I'm talking about that angle right there, BOC. I need an angle that's complementary to it. Can somebody remind me real quick, complementary, what's that? Adds to 90. Got to remember that. Don't get it confused with 180. So can you find an angle that when I put it next to or with BOC, it adds to 90 degrees? Let's find out. 2, here we go. Quincy, can you find that angle for me?
Wait, what? Which one?
Complementary to BOC.
That would be the AOB, right?
AOB, yep. And if anybody had BOA, that's fine too. That's another name of, but you cannot name it angle O. That's no good. Naming it angle O. Good job, Quincy. Supplementary adds to what? $1.80, yep. All right, so what's supplementary to BOC? Something that would add to 180 with it. 3, here we go, Omni. Something that I put with BOC that would add to 180.
EOC.
Woo! Got it. Coming strong. EOC or COE. Again, take a look, everybody. Here's BOC and here's EOC. Notice you put those two together, straight line equals 180. And then finally, give me an angle that's congruent and, adjacent now to AOC. AOC. Give me an angle that's congruent and adjacent to it. 24. Here we go, Emily. What is it? COD, yep. Or DOC, whatever you prefer. Good. It's just not angle O. Good work. Anybody have any questions on complementary or adjacent? Okay, I know you guys don't have that one in your notes. Okay, so let's go to the word problem now. Come on. Okay, I'm done. I know you guys, the next one is this one here, so. There you go. Here you go, example. I know it's example 4 for you guys, but. Okay, 2 angles are complementary. Everybody stop. What am I thinking? What am I thinking right now? 2 angles that are complementary. 2 angles that add to 90. So I'm thinking in my equation I'm about to set up, angle 1 plus the second angle has to equal what? 90. Help me fill in the blanks now. All right, help me fill in the blanks. Degree of the smaller is 50 less than the degree of the larger. So I got to do something with that 50 less than sooner or later. You guys remember writing let statements back in algebra? Did you have to write let statements? Yes? No? Doing word problems? Okay, same thing here. How many angles am I talking about? 2. A larger and a smaller. So you got to decide, what do we want X to be? There's no wrong answer, by the way. It's just a decision you have to make. Good talk. Okay, we'll go larger. So I'll let X equal the larger. If you call X the larger, read the problem. How do you represent the smaller? 50 less than the larger. 50 less than the larger. How do I write that now? Going back. Omni, going back to you. If X is the larger, X minus 50. I got to remember, you come strong. Good work. Now, hey, if I called the smaller X, how do you think you would write the larger then? If I started out with X equals the smaller, what would it be, the larger X plus 50? Okay, everybody good? X plus 50. So it doesn't matter what you started X out with. All right, so let's add them together. So first angle is X. The second angle is x minus 50. Let's rock and roll, everybody. And x should turn out to be 70. I won't ask anybody there. 70 degrees. Guys, all I'm going to say is please make sure you answer the question. What angle did I have to look for here? The larger angle. And what did I call the larger angle in my let statement? X. So I'm done. If I had to find the smaller angle, then I would subtract 50. But this is it right here. Done. 70 degrees. Please make sure you answer the question. Anybody at home? Questions, comments, concerns? Because this next one's a toughie. And then you're going to work on your own. Any questions in here? Okay, let's do this. Two angles are supplementary. Let's stop. What do you know then if two angles are supplementary? Two angles add to 90. So two angles add to a buck. Did I say 90? Sorry, a buck 80, right? 180? One job, Mr. Carlino. One job. Know the difference between supplementary and complementary. All right, what do we know about these two angles? They're in a ratio of 7 to 2. Here's what that means. One angle could be 7 degrees and the other angle could be 2 degrees. Does that make any sense? No, because they have to add to what? Okay, let me keep guessing and checking with you. Let me go multiply by 2. One angle could be 14 degrees, the other could be 4 degrees. Does that make any sense? All right, let me do one more. Let's multiply by 3. 21 degrees and 6 degrees. Does that make any sense? Okay, I'm tired already of guessing checking. I'm tired of it. Who knows when we're going to finally get there? So what I need to know is what number do I need to multiply by 7 and by 2 so when I add them together I get 180. So that's what this equation's for. We got 7, we got 2, and I want to know what we're going to multiply each of them by to get 180. So guess what we're going to put next to the 7 and the 2? Our x. That's what we're multiplying each of them by. Makes sense. All right, because I know 1, 2, and 3 didn't work over here, so I got to figure out what multiplies here. All good? All right, this should be a quick one for you guys. 9x equals 180. X equals, what do we end up here with? 20? Is that one of my angles, 20? Is that one of my angles, 20? No. That's what I'm multiplying 7 and 2 by to get the angles. So ready? Let's finish this. One angle will be what? 7 times 20, which will be 140 degrees. And your second angle, what do I multiply 20 by now? 2. 2 times 20, 40 degrees. And I better do a quick check. They better add to what? 180. Yep. And they do. So again, anytime you guys have numbers in a ratio, stick what next to them? X's and solve. Anytime, because you're going to see that multiple times during the course of this year. Put X's with them. Okay? Questions? Okay, you guys are on your own for the next set. I'll have the answers up on the board so you can check them as you go along. Okay, so you guys are on your own now for the next question. And if you get done with that one before the bell rings, move on to the next question. All right? Make sure you guys check your answers at home as you're doing them. Just don't copy them down. That's not going to do any good for us. If you can't get one of those answers or don't know where it came from, let me know. We'll talk. If you finish all of those, go on to the next one. If you are given two angles are congruent, mark them with arc marks on your diagram. Get used to it. If you know two angles are congruent, mark them in your diagram. And just a reminder, you guys at home, 1 o'clock, make sure that gets up on Google Classroom. I'm here the rest of the week except for today after school. Okay? Have a good day, guys. I'll see some of you guys in class tomorrow. Dig out of your quiz hole. Dig out of it. You got it. Good job, guys. Have a good day, guys. Have a good day, guys. Yep. Take care, guys. Have a good day. Behave.
Thank you.
Yep.
Oh, do you know someone named Amin Patel?
What's that?
Amin Patel.
Oh yeah.
He
Yeah.
said his name and then
He's a legend.
Mr. Carlino,
Yeah.
since I was supposed to be in school today, but I wasn't, how do you want me